Alright, hey everybody, I hope you all are having a great day today. Yeah, mine's going pretty good so far, so let's just get right into programming. One other thing you might have noticed, I messed around with my audio settings, so please let me know if the balance is wrong. Hopefully a lot of my background noise should be filtered out now. But now on to programming. So we were working on the terrain mesh generation for our Tactical Lizard Tamer game, and we're just going to continue with that today. Okay, I can't see it until you rotate the camera a little bit. So right now we have a bunch of hexagons, and they're all connected and share vertices, which is nice. And we started on different elevations, and the game knows that if there's a hexagon that is on a different elevation, that it can't share vertices. So we need to try and hook these up now. Okay, and I forgot, I had a nice little diagram of the neighbor hexagons, which I think would help me explain this next part we're going to do. Let me just open it up real quick. Okay, here we go. So again, this is the column and the row, and then this kind of shows the other neighbors. We'll actually need to get all the neighbors this time, so this is column plus, oops, let's not do it right there. Column plus 1, and this is row, yeah, this should be plus actually. And then corner 3 and 4. And then this one is... oh right, this is actually wrong. It's not column plus 1, it's the same column. Let's scoot that over. Oh gosh, that's a bad C. There we go. It's very hard to draw with a mouse. Okay, so 0, 1, 2, 3, 4, and 5. So that might help us. So here, well, technically, we need to connect up with a corner of the cell that is lower than us. Yeah, so I guess it'd be the first one that's lower than us. Okay, so this part is actually a little bit complicated, and I kind of wanted, so I'm just going to assume that we're just going to have an elevation of 0 and 1, and so we won't like go and search for other hexagons depending on which one is closest to us, because, well, in the future we're not going to be sharing vertices, which is what I wanted to show, so I don't want to spend too much time trying to get it to work, but we might as well just for now. Okay, so again, we'll just kind of hard code this in. If the blueprint cell elevation is greater than 0, then we'll just create some hexagon or some triangles to the vertices below us. So first we need to except that's a little, yeah, because these corners. Okay. Well, I was gonna say that we would go and just search for the hexagons that have been generated already and match up to those corners, but the problem is these up here wouldn't have been generated yet. So we'll have to change some of the code to deal with that. And again, we're not going to be using it. Okay, well let's just make these 3, and then that way you'll be able to see the problem with sharing vertices. Okay, so let's just start with the one to the left. And so we'll want to match, basically we want to do a triangle from 5, 4, 1 and 5, 4, 2. And I'm kind of just going to hard code this in for now. So verts on left equals cellular vertices index -1. Okay, and so we'll want to add a triangle from my corner 5 to my corner 4. Yeah, because clockwise to the left corner 2. Well, actually 5, 4, 1 and 5, 4, 2. So. Okay, and this will look fine, I think. Let's just start up the game and look ourselves. Oh, yeah, I did actually do that wrong. So it should be 5, 4. So this triangle is right, but then this one needs to actually go down like that. Okay, so let's fix that real quick. So corners 1 and then 2. I think, wait, it's 5, okay, so it's 2 then 1, because it has to go around clockwise. And that's an important thing to switch. Okay, so, oh, I did it wrong again. What did I do? Five, 4, 1, and then 5. Oh, it should go 5, 4, 2. Gosh, I'm drawing the right, or I think I'm saying the right thing, or thinking the right thing, but I'm actually putting in the wrong numbers. Okay, there we go. Finally a square face. So again, this looks okay. Oops, to press Alt. And for this art style, we want to have these sharp corners, so it's good. But the problem is, obviously, this right now is unlit, and that's because we don't have normals, and the lighting system needs normals to be able to calculate the shadows and everything. So there's an easy way to do that. Don't need this. We can just add right here, after we add the triangles and vertices, Unity has a way to calculate the normals automatically. Where is it? Yeah, recalculate normals. And again, if you're not familiar with that, a normal is basically just a vector pointing outwards from the face of a mesh. And I'm pretty sure now we should be able to see what's going on a little better. Okay, so now there's lighting. But you can see there's some weirdness here. And it's kind of like the shadows all messed up. Or the blending. It's actually hard to... I really need to get better camera control in-game, but... And again, it has to do because we kind of want... or not kind of, we do want these sharp edges, but... Right now, this normal, I think is pointing like 45 degrees outwards, when really we need it for this face. The normal needs to point out that way, and then the top needs to point straight up, and that would give us this sharp corner, and I think it would also fix this shadow issue. And unfortunately the only way to do that is if you actually have a separate vertice for every triangle. So all that work I did last time to try and get all these vertices to share was I wanted to show this error and how come we are not going to be sharing vertices for this art style. So really, a lot of this work that we did is not going to be too useful. So this add triangle right now, we pass it vertices, but we could actually just pass, or we pass it the vertex index, but we could actually just have it pass the vertex position. Oh, I'm sorry, it looks like my volume is clipping a little bit. Let's try and fix that. Okay, I hope that's a little better. Again, please let me know if the volume is too quiet now, but it looks okay from my levels. But anyway, let's get back into here. So again, right now we pass triangle indexes, but we can actually just pass the vertex positions now, because we're going to assume every triangle is going to have its own vertex. So I'm not even sure if we'll need these helper functions anymore. Just a second, I need to get a drink of water. Okay, let's see here. So I guess I'll just comment those out for now. And we'll just pass in positions. So we get vertex index is just the vertex or vertices list count, and then we'll add these 3 positions. And later on, if we see that we're adding triangles that could actually share vertices because they have coplanar triangles, which basically mean the triangles don't bend in the middle, then we can have those triangles share vertices. But we'll worry about that later down the line. No reason to over-optimize right now. Okay, so basically we'll just so we don't do this right now, we just get the center position, and we don't really even need to keep track of the corners. But I guess I'll keep this in case we have like some metadata about neighbors that we need to keep. I'm not sure. The nice thing about not having to share vertices between hexagons is also that every hexagon is kind of independent in its generation, which is pretty nice. So that's why I'm not sure if we'll need this storage. Definitely won't need the corners anyway. But I'll keep that functionality in case we do need it sometime later. Okay, so this wants to add every triangle, so yeah, we can do that. Okay, yeah, I was just thinking, so we'll add center, and then yeah, this won't be the most efficient, but that's okay. So we have get corner, I, X, radius, and then we add the center. and then we do the same thing except for the next corner. Again, we need to make sure that we wrap around if we set I equal to 6 here, because it needs to wrap back to 0. So that's what that modulus operator does. And I think that's it. Yeah, this is useless now. And let's comment this out and just see if everything still works okay. We've got some errors. Oh, obviously, because I need to get rid of these functions for now. Okay, there we go. Okay, so now we're back to how we were before. We still got the nice shadow there, which the lighting system is working. If I change the direction of this light, yeah, we can see it is affecting the way that the mesh is lit, which is good. So now everything's the same there. So now let's try to add this elevation. So basically what we'll need to do is cycle around every neighbor, and if the neighbor is below us, we should create just a square that goes downwards to connect up to its corners. This is just going to be the absolute simplest cliff, and it's not going to look too good, but it will be okay for now. What was I looking for? Yeah, I think in the hex position class we have a way to get all the corners easily, or all the neighbors easily. Oh yeah, these axis vectors, which are basically the left, right, and so this way we can just loop through this to get all of the neighboring hexagons, and we won't have to calculate it ourselves. Okay, so let's see. For each neighbor, if we have a greater elevation, create a cliff. Alright, so our position so we have the column and the row, and yeah, we don't really care about the layer at this point. I guess this should go outside, shouldn't it? I guess we can just use this, why not? Okay, so we want to get the neighbor. It's my position plus hex position, axis vectors I. And then, so now we need to convert that to the neighbor index. Which is the row times the row size plus column. guess we could maybe put this as a helper function inside hex position. But I don't know how often we'll be using it, so I'll just leave it out here. And then, okay, so now we need to get the blueprint cell for this. Okay, so now we can finally check the elevation. If neighbor cell elevation is less than my elevation, then we create some more triangles. Okay, so one question here is, do these axis vectors match up with the way we define corners? It'd be really nice if they did. I'm not sure if they do. Okay, so this is look to the left. So ideally, axis vector 0 would point to this one, which is one row up. How often do I use this? Okay, it's used just to loop through everyone, so I don't think it would matter if we rearrange this. Because what I really like is for the axis vector I to point towards the hexagon that, and then this corner I is also the first corner in our shared edge. So this one has corner, so neighbor 0 has corner 0, neighbor 1 has corner 1 here, so on. And I think it'll be okay if I rearrange this. But now I'm trying to think, maybe instead of numbering these, I should have like an enumeration for hexagon corners and also the I wonder if the game logic would ever need this code to get the corner. Because if so, then I should put that code into here. Okay, so let me see here. So for corners we have north, and I guess northeast, southeast, south. Okay, so that's pretty easy. And public neighbor. So for neighbors we actually have northeast. Yeah, northeast, east. Okay, so it's a little offset. And maybe I should put a little comment here. Corners and neighbors are arranged so that neighbor I has corner I. How do I want to say this? It's like it has the first corner when you go clockwise around the hexagon. First clockwise on shared edge. That makes sense? Yeah, adds first corner clockwise on shared edge. Especially on shared edge, clockwise. I kind of know. It makes sense in my head, but this is a little confusing to write out. Okay, so now let's change this. So this needs to point to the first neighborhood, which is northeast. Okay, so let me move this over here so I can look at both windows at the same time while I do this. So this is the same column, but it has +1 row, and then next is +1 column, same row. The next is +1 column, -1 row. And then next is the same column, -1 row. And -1 column, same row. And then -1 column and +1 row. Okay, so looking at my diagram, I think everything's right here because the column kind of goes diagonal that way, and these all have the same, and the row is obvious. Same, and so negative, column, plus column, minus row, and plus row. Okay, so I think that's all right. And let's see here. And I guess we could even, like, I think this code should probably be taken out, and we don't have this hex radius. Let's see about that. And this is actually a vector. Well, I'll just leave it a vector 3. All we do here is we just don't include the hex radius. And I was thinking that we could, like, pre-calculate these cosine and sines, which would speed things up a lot, but I don't think it's super important right now. Maybe just to be helpful, I'll also let you pass in the corner enumeration. And I guess I could do the same thing with this. That would just be axis vector 2D. Why is it not like that? Oh, because it's hex position, not a vector 3. Okay, so now in this, we just return x position, get corner offset I times hex radius. Okay, so I think this is all good. No, I don't even remember what I was going in there to do. Oh yeah, because I wanted to... Yeah, there's a little trickery we can do to, like, flip the corners around so we can get the corner offset for our neighbor. I think I might even make a little helper function right here so that I don't have to write some code for that. So it'd be get neighbor corner offset. Maybe I'll let them both be integers. I guess we should pass to the neighbor. Okay, so what it is, it's gonna give us... Is that actually helpful? No, because it's this would be actually the same as getting the corner offset. Because, yeah, that's equivalent. Yeah, so I think I'm thinking too much, getting ahead of myself. Let's go back to here. So what I actually want to do is I want to add a triangle down to the neighbor's elevation. So let's see. Vector 3. I guess my corner A is yeah, and so the way I've done this is so that neighbor I, the first corner is also I. That's the whole reason I went down that rabbit hole in the first place. And then corner B is, again, we need to cycle through here. Okay, and for the neighbor, I guess first we need to calculate the neighbor center. Yeah, and there's, we could definitely speed this up. In fact, maybe I will. Or we're trying to say we could definitely, I guess, speed up, but make this way more efficient. So this would be corner A flat. Oh, right, no, let's call it corner A offset. Because all we have to do is just change the elevation down to the neighbor. We actually don't even need to get the neighbor center, I just realized. Vector 3, corner B, offset is this code. And then of course my corner A is that. Okay, and oops. So really the neighbor's corners are the same as my corner, except the elevation goes down to the neighbor's elevation. Which the Z is really just the layer times the hex height. Okay, so yeah. Neighbor corner A is my corner A. Alright, let's write it this way. So new X. Okay, so the Y is actually the elevation. Is that how I did it? Yeah, this is a little confusing because I just flipped it right there. Yeah, this is going to cause me headaches on the line. Okay, so the Y here is what we need to change to be the neighbor's elevation, so we can just call neighbor cell elevation times blueprint height step. And there we go, I think that's gonna do it. Oh, except I need to get corner B, of course, and then I need to create the triangles. Okay, and now add, so we gotta add 2 triangles, and I think it's my corner A, my corner B, and then neighbor corner B, and then the next one is my corner A, neighbor corner A, and oh, I get to put it backwards, it's neighbor corner B first. Okay, so I think it should be golden. Let's try it out and see. Oops, got an error. Argument out of range. Not gonna open it up for me. Create cell 63. Really? Oh, of course, if we're a border, then the hex position might be out of bounds. Okay, so let's... So right now we have this 2 board index. I guess we still want to have, but I should make basically copies of these that are in 2D, so... They only care about the row size. Oh wait, I don't have the field obviously, so... And then public is valid on 2D. Okay, so this one actually need to know the total row size, or the number of rows. It's not quite as helpful. Okay, I guess I'll just pass num columns and rows, although this really isn't going to be that helpful. No, that's not what I wanted to do. Okay, so again, if neighbor is valid on 2D, and this is the blueprint row size, I guess we can calculate the number of rows up here. That's just blueprint cells count divided by the row size. Yeah, this little block is starting to get pretty big. We should probably separate it out into a different function soon. The neighbor index we can actually just use the neighbor class. So maybe I can just go like this. Neighbor get our index. Okay, because we don't need that in any other place. Okay, so let's try this now. I think the error was just that it was trying to find a neighbor when it was on the border of the world, so obviously there's no neighbor there. Okay, so now it's working, but okay. Yeah, you can tell here we wound these counterclockwise, so all the vertices are inside out. Or I should say the faces are inside out. Yeah, because we actually... Right, because we have to look outwards. So basically, if I start there, then I need to go to the neighbor corner A, and then neighbor corner B, and this one, neighbor corner B, and then my corner B. I think that's going to be wound up correctly. Yeah, looks good now. Okay, so yeah, this looks much better. Before, all these corners were all smudgy and the shadow was messed up, but now the corners are sharp. The shadow looks nice. Okay, yeah, so this is what we want to look like, and again, this is why we can't share vertices. Now you might be thinking, why don't all of these hexagons share vertices? Because they're coplanar, but well, they could, but somewhere down the line we're going to be adding bumps and all kinds of stuff to make these more interesting to look at, so they won't be coplanar for long. It looks like now we've got elevations complete for now, and we've already started a bit on the lighting. Actually, I think we finished this at the same time. So now I want to work on mouse picking. So I remember there was some kind of bug with trying to get the monsters to be able to move. But before we had it so the monsters could select a block to move to. Oh right, I have the UI canvas off because it's hard to see anything. So if I select gold monster, okay, now it works, so I'll just use the normal old move. And so it's telling me I can move here, but there's no way to actually select these because our old block picking code relied on the colliders on our old hexagons. So yeah, if we bring up our old mesh, just like this. And so now that let me pick it because we have colliders on these meshes. If we look here, down here I have a mesh collider. So we're going to want to do the same thing, except we'll be using the terrain mesh. Now with colliders they can share vertices. So maybe I should have kept that code I had before. Oh okay, good, I didn't delete it all. And also, I'm gonna duplicate a lot of this code here, but it won't really stay the same for long because like for the collision mesh you really want it to be as simple as possible. So basically the way the game looks right now is pretty much as good as you'd want for the collision mesh, because we won't want it to be bumpy and everything. So let me start on that. So we have the graphics mesh generator. And I guess we could try just like throwing the graphics mesh into the collision mesh, but I know down the line I'll want to separate them. So while this code is very simple, we might as well use it. So this will be the collision mesh generator. Okay, so for this, I'm basically going to need to make another mesh. So we've got to go back up to the terrain mesh. Okay, so we'll name it something nice again. So I guess this will be the terrain collision. Okay, so yeah, we'll just need to create the collision generator, and it will again just use the same blueprint. So collision gen. And yeah, we need to pass it the correct mesh. And then we'll need to get a way to grab that. Okay, I think that's looking good. So this will basically be the same, and actually the cell vertices will need to have our corners again, because like I said, collision mesh can share vertices. Guess I should have copied this before I deleted all that, but luckily most of the code is still here. And it won't need normals. Or does it? That's a good question. Let me look that up. Unity mesh collider need normals. Let's see. If a mesh is used only by mesh collider, you can disable normals and import settings because the physics system doesn't need them. Okay, well that's good. So in case the mesh collider to work properly, you need to tick the read write enabled. Okay, well I don't think... do not have... okay, so unfortunately... well, this won't apply to us, but because we won't actually use the physics system, we're just going to use it for ray casting. Yeah, because unfortunately our mesh will not be convex because we can't guarantee there won't be any valleys. Alright. Okay, so I need to get rid of this and bring back these functions. I thought I just added back the corners. Oh, I made it private again. Let's get rid of this so I can actually see. So all this is the same. And yeah, this is where I find the corners, so all I have to do here I got figure corners, and then I've just got to add the center vertex. I think I remember how I did this. So add vertex center, and then we'll just add triangle, center vertex, and center vertex. Oh wait, no, we gotta do the corners. So let's see. Storage, corners, I. And then storage corners, I plus 1, modulo 6. Okay, so we will need to go through and figure out all this to do with elevation, but I'm just going to test this code to make sure everything is working. Okay, so this is the graphics mesh. Let's do it this way. Let's have an empty game object that'll just be terrain, and then we'll parent both of the other meshes to it. Okay, so this display link needs to actually go on the parent. This will be a display mesh, or let's call it visible mesh. I'll just copy it, and this will be the collision mesh. Okay, so here we don't need a renderer. We still need a mesh filter, and then we need a... You might be wondering why we can't use Unity's terrain. It doesn't work well with sharp corners, which is basically the reason why I'm writing this myself. Okay, so yeah, not convex. Don't need a material. Okay, so it doesn't need a filter? Alright, so I guess the filter is just for the renderer. That's fine. And terrain display link. Okay, so let's edit this. That makes this a little easier, so get parent and children. And then get component and children mesh collider. Equals terrain collision mesh. Okay, so I think we're good. No reference. Oh, I didn't create the corners array. It's funny, I'm surprised that... Well, I guess that the graphics mesh was created before this code ran, which is why the graphics mesh actually gets displayed still. Okay, so I don't know if there's any way I can just visualize the collision mesh, but they really should look about the same. Although that is a little weird that it says its position is different. Let's see. This looks how we'd expect. It's not going to show up in the editor, is it? Let's add a renderer to it. Oh, that won't work either because it needs to have a filter. Can I just do that? No, it's not gonna. Can't just copy it over. Okay. I think the easiest way to be able to visualize it would be if I can update the ray casting code to actually interact with it. I think this will, but I think it's going to throw an error. Okay, no it doesn't. Let's look at the ray casting code. Where do I do that? Indicators. Oh, it's not on a... Yeah, it's not on a mono behavior, so that's why I wasn't seeing it up there. Mouse pick raycaster. Okay, so it has the field layer. I'm surprised, I thought this would have thrown an error because there's no block collider on it. Did I set the layer right? Okay, so obviously the thing is going a bit awry. Oh, there it goes. How come it didn't show up before when I disabled that? I don't know. Whatever. So it's only going to show up when I click on it, which I guess is fine. So then here... Okay. Why did it not work before? Okay, but anyway, at least it's mouse picking. I guess I'll just comment this code out for now, because I really just wanted to draw Ray to work. Just gotta finish compiling. It's not hitting it there. Why? Seems to only activate once I transform it. It's a little weird, isn't it? Shouldn't need to be woken up because it doesn't have a rigid body. Okay, maybe there's some function I need to call after I set a mesh to get the collider to update or something. Just want to spell collider. See here, I don't see any update or like refresh or anything. I was gonna say that doesn't seem very Unity to have to do that. It should just update right here. Maybe if I just mess or like reset the transform, it'll do it itself. No, it still seems to not be happy. Yeah, it updates like once I mess with the transform. Maybe I need to wait one frame before I set it. Like it hasn't updated itself yet or something. Okay, so let's void update. I don't think I can. I was gonna say I could just use a coroutine But I don't think since I overrode the start that I can use a coroutine with this mono behavior class I have set up here, so I'll just do this old-fashioned way. First update. Oh, now I'm gonna need to store this. Hopefully I won't have to do that. There's an even fancier way I could do this by using the enabled variable, but I might need this update for something else. Okay. So if I wait one frame, that should let... No, that shouldn't have caused it because, yeah, the collision or the mesh collider has been sitting around here for a while the mesh is getting generated. So maybe if I do that, it wakes up. Oh, you know what? It's because at this start frame, we set the collider object, but the vertices haven't been generated yet. So let's see here. I guess maybe it doesn't update itself. Okay, is there... I forget, do I have a messenger that's like... when it enters the play scene? Probably there is one. Whenever these monsters get created. Okay, on this realized map. Okay, so let's use this to set up everything. Okay, so I guess I'll just call this setup collider. Now I don't need to hook into the update function at all. Okay, so yeah, I guess this is called probably, let me look and see. On the map controller. Okay, yeah, so it says called once the scene or the map gets started. I don't know, it's a bit hacky, but it will work for us now. Okay, so let's see, is the collision mesh? Okay, good. Okay, so I guess, yeah, that's one thing to remember. The way the mesh collider works is I guess it grabs all the data from the mesh when you set it, and it doesn't like update automatically whenever the mesh updates, so that's good to know. And it's kind of hard to see, but all the light green is the collision mesh, and so obviously right here there's no vertices for the collider because we haven't added. It's really hard to see. Okay, so you can kind of look, if you look here in the scene view, whenever our raycast turns green, that means it's hitting the collider, or hitting the terrain. Oops. And when it turns red, it hits a monster. That light makes it hard to see, but then obviously when it's black, it's hitting nothing. So right now I'm going through the hole in between the different layers. At least I thought it was. So now, obviously, I need to set up. Oh, what's in the like with this? Oh yeah, it's saying it's obsolete. That's okay. Okay, so rather than deal with the cliffs right now, why don't we update this to actually get the correct block. To do that, I think from our raycast we can get the triangle that was collided with. Let me see about that. Do I not even have? Oh yeah, I have the raycast hit right there. So hit. Okay, this center coordinate of the triangle we hit. That's not going to be very helpful. We actually just want an index for the triangle. Well, we could use that if we have to. Oh yeah, triangle index, that's what I wanted. Now that I think about it, the UVs might be a little easier. I don't know. Because we could we could store numbers in the UVs that tell the game which block was just hit. But then what do we do if the vertices... Because the vertices are shared, so that means they have the same UV. Yeah, that's probably not... We'd have to go back to not sharing vertices to do that. Okay, so we have a triangle index. I guess the easiest way is if the collision mesh kept track of the index for every cell. I mean, like, you have the cell for every triangle. Actually, what does that mean? Is triangle index, is that the index in the triangle array? I hope that's what it is. Probably go look that up. Raycast hit. Really, it's not going to show me? I guess I want the scripting API. That's what I was looking for. Yeah, there we go. So the triangle index is only valid if the collider with hit is a mesh collider, obviously. Paired mesh showcases vertices and triangles. Okay, I see. So yeah, it's the actual triangle that we hit. So then if we multiply that by 3, we can get the index in the triangle array. And then from there we can get the vertice. So basically, yeah, for every triangle, all we need to do is store the index of the block for that triangle. So that shouldn't be too hard, actually. So the collision mesh generator will output also that triangle data. How do I guess we'll just create that list and then the train mesh will expose it. Okay, so I guess we'll do int. I was just trying to think about how I want to do this. So this will be triangle owners. So there's a blueprint. I guess we will need the layer size after all because we'll want to give it the correct value for that. But I don't want to give these generators the actual board just because I don't want it to be coupled to that. So yeah, row size, public int, layer size. Okay, so when we add a triangle, I guess we should just pass the owner index, which is not necessarily this because we have to add on the layer. Okay, so let's do it this way. I guess block index equals index plus blueprint elevation. Oh yeah, it's my blueprint. So blue cell elevation times the layer size. And then we just pass that here. And then we just add that to triangle owners. Okay, so now I need to expose this. I guess here I should clear triangle owners before we do anything else. Probably while I'm here I should clear cell vertices. Okay, and then in the terrain mesh we need to make that list available somehow. Let's actually not make it available directly. Get owner block for triangle, and we'll just return the. Okay, we don't actually keep this. This will be the collision triangle owners. Wait, no, I don't create it, I just copy it from here. And then this is really simple. I just pass that along. That's just so we don't expose this list, so that way other classes can't tamper with it. Not that I would, but just to keep a little more separation of code. In this raycaster, we'll just need to get a reference to the terrain mesh. Terrain, and since this is in the UX, it's fine to do. Oops, that's not what I wanted to do. I wanted to. Really, it's not going to let me resolve the dependency. Oh, that's going to cause a problem, isn't it? I guess I should rename it now before it's too confusing. What do I want to call this? Maybe I should just rename the namespace to terrain. Okay, there we go. Let's actually move this up here. Get component, terrain mesh. Okay, so select, when we set the select block, do I actually need, okay, no, it's just the index. That's good because that's what the train mesh has, so I don't have to convert the index into a block or block position. So it's a sketch. I'm gonna block for triangle. Then we just pass it the hit. Triangle index. And then let's turn on this, I guess. So it can spam our debug log, but we want to be able to see what blocks we actually are hovering over. That's interesting. So I'm not getting any debug logs. How come? But if I click, do I get an error? No. Okay, let's try and select a movement and see if it works. It does. Okay, well that's cool. So the movement does work, so obviously selecting is working. It's just the debug log isn't firing. How come? Mask. I guess this subscription isn't working right. What I need to do. Yeah, this should fire, but it doesn't, obviously. Okay, well, it's not causing any problems right now, but so I guess, let's just move this. Move this here. So yeah, we'll get the same functionality. And I won't need to try and debug that. Okay, so now it's going to mouse pick none. Let's pick block. So 0, 1. Let's, if I zoom in, oh, it's kind of hard to see exactly the transition, but it looks like it's pretty close. 2, and then up here should be 5. 24. So yeah, it looks like it's working perfectly, except obviously there's no collision on these walls right here, so it just goes through like to the one behind it. So leave that out for now, and I guess let's try and fix that wall. Now before, when we were trying to do elevations with shared vertices, I just made it really simple by only trying to share with vertices that we knew. What am I trying to say? With vertices that had already been generated. Sorry, brain fart. But I guess what we'll need to do now is we'll need to make sure that the vertices below us have all been generated correctly so we can hook up with them. Yeah, that's one way to do it, so we can just cycle through it one elevation at a time. Another way to do it is just that we could just build these walls behind us, and then yeah, that's probably better because then we can guarantee that the vertices have already been generated, so we could like build these 3 walls either up or down. First I was thinking we would just always, the hexagon we're generating now would be what's the word, have the responsibility to build all walls downwards, but I think it doesn't really matter. It can also build walls upwards, it just needs to hook up with all of the hexes that have been generated before it, which would be any below and to the left. We can hook up with neighbors 2, 3, and 4. So for corners 2, 3, 4, 5. I think, yeah, that should be fine. And then we'll leave these corners to, yeah, well, in the corner array. At first I was thinking we might need to update the vertex index, sorry, can't talk, vertex index to match the vertex that's on the top or bottom of the cliff, but I think if we do it this way, we should just leave it on the coplanar vertex so that the one below or the next vertex can, sorry, the next hexagon can just match up with that. So I don't know if that made any sense, but I think best thing to do would just be to start coding it. So again, we'll just make the walls for hexagons that have already been generated, which are the ones below and to the left. And if we're the first row, then these 2 would not have been created, and if we're the first column, then this one wouldn't have been created, so we'll have to also take that into account. So yeah, I don't actually think any of this code is going to be any useful, so actually probably let's just write the one to the left and see if I can get that working. So if column is greater than 0, then we'll have so what do I need here? I guess I need to get the cell vertices for that left neighbor. It'll be actually a lot like this code. So maybe we can kind of well, no, I'll just leave this because this is where we're filling the corners array. And if we're at different elevations, then we don't share, which is what we want to do. I don't know. Yeah, we could probably mix these functions together somehow, but let's just try it like this. So this is cellverts, my index -1 because there's 1 to the left. So what do I need to do here? I need to add another triangle, but all of these vertexes will have been created already, so I don't need to worry about that. So I guess the triangle is just I think I could just simply just go down to the this left's corners. So it's kind of like the code I did before, actually. So it will be, and again I need to look from the outside towards it so that they're wound correctly. And I think that would be my, for this one actually, we can use this corner. So it's my 5, my 4, and then neighbor 2. Yeah, this is exactly what I did before, so hopefully I don't mix everything up again. And then my 5, their 2, their 1. Okay, so storage, corners, 5, corners, 4. Oops, looks like we dropped some frames, sorry about that, but I think it's leveled out now. And then left, corners 2, was that right? Yeah. And then I need to give the owner block, which is me. Oh, actually it could be the neighbor if it's higher than us. Okay, so yeah, we need to look at that. Neighbor index is index -1, just so I don't have to keep recalculating that. And then I guess I'll rename this to neighbor storage. And then neighbor cell is, oops. Just trying to name it before I actually give it a type. That's not blueprint. Blueprint cells. Looks like I did it again. It always seems to give me the opposite variable that I want when I name things similar like that. Okay, and then so triangle owner is neighbor cell elevation greater than. Oh yeah, so that's another thing we need to do. Before we even do this, we should check to make sure that the elevations are different. So if neighbor cell elevation does not equal my cell elevation, then we go through with this, because if we're on the same elevation then there's no cliff obviously. Okay, and then if it's greater than mine, then the triangle owner is neighbor index, otherwise it's me. Oh, except in order to get the neighbor index we've got to add the elevation. So plus neighbor cell elevation. Okay, this is starting to be a little bit too complicated. So let's try to break this up a little bit. Okay, there we go. That's much cleaner. Okay, so we kind of need to do this for this edge and this edge, but let's just test this one side and see if it works correctly. Okay, so let's look. It should be this corner, or this cliff, I think. And it is green. Okay, that's a little confusing that the triangles go opposite ways, but I guess it doesn't make any difference. So now Oh right, it's on the silver side. Oh wait, did I? That confuses me. Because 1 is here, and to the left that should be... What is it? Okay, so that triangle doesn't exist. Well, I got the winding wrong. But I thought that this side should have been the one that had the triangles. Wait, maybe it does. I'm confused. No? I don't know, maybe. Okay, so I created one triangle on each side. How in the world did I do that? Okay, let's look. Oh no, because I only added one triangle, I needed to do the other one. I got sidetracked trying to figure out the owner. Okay, so I did 5, 4, 2, which is 5, 4, 2, and then I need to do 4, 2, 1. Oh wait, 5, 2, 1. Oh, and that's it. Of course, because the other one... Yeah, I was surprised that the side on the... or the silver monster side of the board also had the cliff. That's because it was being created by the other hexagon. So yeah, that's fine and perfect. That's how it's supposed to work. So now let's get rid of the visible mesh. It's a little hard to tell. Oops. It'd be nice if there was a way, but I can't do it. Can't see anything. It'd be nice if there was a way that you could get the collision meshes to be shaded, but I don't know if that's possible. Now here... Oh wait, no, it's not that one, it's this one. It's staying green the entire time I move over it. I need to turn back on the debug log, don't I? So I can actually see what block is being hovered over. I had a feeling it was a bit too early to comment that out. Okay, so again, it's this face here. And so that's block 12, and so it's the same as the top, which is what we want. It moves to 11 when you go down, which is obviously the one to the left. And then on the other side, it should work the opposite way. So yeah, this should be 13, and then when we move up here, it goes up to 12. Okay, good. Also, I just realized there's probably another way that we can optimize this collision mesh. Like, for the, again, we don't want to do this for the graphics mesh because we're going to make it much more complicated, but the collision mesh, it's going to be pretty simple. And you can actually tile a hexagon with 4 triangles instead of 6 like we have now, so I might, I guess tile's not the right word, but you can fill a hexagon with just 4 triangles instead of 6, so we might do that. But I think, oh yeah, I am out of time unfortunately, but we got a lot done today. So I'll leave this because we need to do the bottom cliff faces and maybe optimize hex triangles to 4 instead of 6. That might be kind of fun to do, but I don't know if we might have to revert that later. I guess it depends if we ever want to raise the hexagon faces at all, which I don't think so. I think it'll just stay flat. For the collision mesh is what I'm talking about. But anyway, yeah, I guess I better get going. So thanks everybody for coming by and watching. I do appreciate it. I hope that my audio setup has been a little better. I know I did have a little clipping, so I apologize for that. Hopefully it should be taken care of now. But if you missed any of this stream or any previous one and you'd like to catch up, I do upload all of my streams to YouTube. You can get there by typing !YouTube in chat or looking in my channel description. I also have a Discord channel if you'd like to chat with me. I'd really appreciate it. It's kind of a small group right now, so we'd like some more people to talk to. You can get there by typing !Discord in chat or again from my channel or video description. Also, feel free to follow me here on Twitch to be notified when I go live. It should be, well, normally it's around 8:30 Eastern, but I might be late or not be able to stream tomorrow. I think I might have to work late, but I'll announce that on my Twitter if I do. And yeah, that's about it for me. Again, thanks everybody for watching. I do appreciate it, and I hope you have a great night. All right, bye-bye.